Okay, I'm going to try to make this as short as possible because I know that you all don't want to listen to me speak. So that being said, this is 4-1 angles of triangles. We're going to start off with some vocab. You should already know these vocab terms in a sense because you already wrote them down. So first one, auxiliary line is an extra line or segment that is used to help analyze geometric relationships. So basically it's an extra line that we would use to try and find the angle for some part of the triangle that we don't know, or square, rectangle, whatever shape it might be. Remote interior angles are angles not adjacent to an exterior angle. So if we had a triangle here, our exterior angle would be here. Our remote interior angles are these ones here. And finally, a corollary is a theorem with a proof. That follows the direct result of another theorem. A few theorems that we are going to go over. First one is the triangle angle sum theorem. This theorem says that the sum of a triangle, the sum of all of its measures, all of the angles, is 180 degrees, which is something you should already know. The second theorem here is the exterior angle theorem. So remember, we were given a triangle that looks something like this. There's our exterior angle. And it says the measure of an exterior angle is the sum of the two remote interior angles. It's the sum of the two remote interior angles. So that would mean, so if I labeled these A, B, C, call this one D. Our remote interior angles are the ones not adjacent, so these ones are the remote interior. So that would mean that this exterior angle are those two added together. That's all that means. A few corollaries to go over directly related to these two ideas, these two theorems. The triangle angle sum, so directly related specifically to that first theorem there. The first part of this says that acute angles of a right triangle are complementary. As a little reminder, if you don't remember, complementary is 90 degrees. So if I had a right triangle, those two acute angles, so if I labeled my angles A, B, and C, that means B plus C will equal 90 degrees. And in 4.2, the triangle angle sum corollary 4.2, there can be at most one right or one obtuse angle in a triangle. So, in other words, if I was to try and draw a triangle with two right angles, I'm not going to get anywhere. So that obviously won't make a triangle to have two right angles. And if I have two obtuse angles, so I would have an angle like that, or like that, that's obtuse. If I was to try and draw another obtuse angle, it'd be something like that. And again, I'm not making a triangle. I can have three lines in a triangle, and that's not going to work. So, kind of just prove that that doesn't work there. And just as a reminder as well that this symbol means triangle. And we're going to go over a few examples. I think I have 4 examples here that we'll go through. So the first example, we want to find the missing measures here. So we can start off right away by looking at the fact that this first triangle here has 2 angles. So we know that a triangle has to have 180 degrees. So if we start by finding the measure of angle 2, I know that I have to have 57 plus 71 equals, plus whatever angle 2 is, or angle M, equal to 180 degrees. So if you subtract off that 57 and that 71, you're going to get minus 71. You're going to get that angle 2 is equal to 57 degrees. All right, the next one that we can do, so we have this now. The next one that we can solve for is we know that these 2 angles are on a straight line, meaning they are supplementary to each other. So I can have 57 degrees. So for the measure of angle 1, I've got 57 degrees plus angle 1 is equal to 180. Again, subtract off that 57, and you're going to get that angle 1 is 123. Which means that we can finally find that last angle, angle 3. And I'm going to have that 123 plus 28 plus angle 3 equals 180 again. Because again, I know that 180 degrees should give me a triangle. It's supposed to give me a triangle. If it doesn't, then you don't have a triangle. So subtract off that 123 and the 28 from both sides. And you'll end up with the measure of angle 3 is 29. So I am not going to go over this one. I'm going to actually leave this one kind of for you to try, and I'll put in the boxes on Edpuzzle for you to see if you can get them right. So you're finding in this one the measure of angle 4, measure of angle 5, measure angle 6, measure of angle 7, measure of angle 8, and measure of angle 9. Just as a reminder, because these guys here have that symbol, that means they are congruent. So whatever you find for 8s should be 9. These are equal to each other. I would go through and find out what all of your angles are first and then put them into Edpuzzle. So don't just answer the question as it comes. I would figure out what all of them are first and then do the Edpuzzle part of it. Use the same ideas that we did on the last one. Look for some straight lines. Maybe try and see if you have a triangle that has 3 sides or 2 angles of the 3 already given to you and start there. Otherwise, you should be okay to figure this one out. I believe in you. Next example here, we want to find the measure of JKL. So this is asking us to find this measure right here. So we have an exterior angle that we're given, and we're given, let's see here. Okay. We are told in the corollary that the acute angles of a right triangle are complementary. Right here, the exterior angle theorem. So we're given an exterior angle, so we might want to use our exterior angle theorem. And we're told that the measure of an exterior angle is the sum of 2 remote interior angles. So those 2 remote interior angles, the non-adjacent angles to the exterior, add to be the exterior angle. So that's where we're going to start. So I have my exterior angle, which is 2x minus 15, equals these 2 added together, so x plus 50. And this is just an equation that we can solve. So if we move an x to the other side, we've got x minus 15 equals 50. Add that 15 on over. So now I know that x is equal to 65. And it wants to know what is that angle. I'm looking for the measure. I don't want what x is, so I'm going to plug it back in. So I'm going to have 2 times 65 minus 15. And that is going to give us 115 degrees. That's it. That's all it wants. Last one, find the measure for each of these numbered angles. Again, this should be fairly simple. We know this is 90 degrees. I know it's not a labeled angle, but we can't assume anything about any of the other angles. Again, we know this one's 90, so angle 1 should be fairly easy. We know that because it's a 90-degree triangle, the angle that isn't 90 degrees, or the 2 acute angles, should add to be 90. So I should have 52 plus angle 1 equals 90 degrees. Subtract off that 52, which means that angle 1 is going to be equal to 38. So we've got that one. I also know that this is some kind of rectangle or square based on the fact that all of these are right angles. So we know this one's going to be a right angle because a square, rectangle, anything like that has to be 360 degrees. So I know that's going to be a right angle, which means that I can find angle 4 fairly quickly. And again, I know I'm going out of order, but it'll be all right. Because I know that it should be 38 plus angle 4, equals 90 degrees. Again, subtract off that 38, and then you're going to get 52. All right. Since I have a line that means that has to be equal to 180, which means this other side is also going to be equal to 90. So I can now solve for angle 3. So the measure of angle 3 should be 52 plus angle 3 equals 90. Subtract off that 52, which means that angle 3 should be 38. And again, I know that corner is a right angle, so the measure of angle 2 is going to be 38 plus angle 2 equals 90 degrees. Subtract off that 38, and that's going to give us 52. And you're good to go. So that's all this is. We'll do some practice with it, and we will move on from here.